Okay, for example 3 in section number 5 of chapter 1, we're asked to use the product rule to differentiate this over here. Okay, so now to do that, we have to identify our two different functions. So what I'm going to do is I'm going to write them in different colors here. What we're going to do is we're going to take the first function, I'm going to write it in a blue color, and then we're going to multiply the second one. We'll do that guy in a yellow color. So if I want to, I shouldn't write equals, if I want to take this new thing and take the derivative of it, okay, that would be the following. Okay, so if I want the derivative of the whole thing, that's going to be equal to the derivative of the first times the second function. Not the derivative of the second function, just multiplied by the second function, plus the derivative of the second function now, times the first. I'm going to run out of room here. Okay, so this gives us, now the derivative of this guy is 2x plus 2. And of course we have to, that's this derivative. Of course we have to multiply it by this derivative. Excuse me, by just this function. Plus the derivative of this guy times the first guy. Like that. And now we'll just go ahead and we're going to reduce here. Okay, so I'm actually going to do my multiplication in. So this is going to be 2x to the fourth minus 8x to the third plus 2x to the third minus 8x squared. This one over here will be 3x to the fourth plus 6x to the third minus 3x squared minus 8x to the third minus 16x squared plus 8x. So let's see here. Let's check out my guys to the fourth power. Here, that's it. So it looks like I've got 5 of those guys. Now let's check out our guys to the third power. Okay. So I've got -8, -8, and +8, which gives me just a -8 x to the third. Then I've got this guy squared, this guy squared, this guy squared. So I have -8, -3, which gives me -11, and -16, which gives me -27. And then I've just got one little x guy left over here at the end, all by itself. Okay, so this right here is the derivative of this function up here. Now they ask us to check it out by actually multiplying first and then taking the derivative. So let's go ahead and do a little check here. So the check is to multiply these two guys together first and then differentiate. So we've got d dx of, now let's multiply this out. So I've got x to the fifth minus 4x to the fourth plus 2x to the fourth, okay, minus 8x to the third minus x to the third plus 4x squared like that. 1, 2, 3, 4, 5, 6. Okay, so that looks pretty good. We'll find out in a minute. So this is x to the 5th minus 2x to the 4th minus 9x to the 3rd plus 4x squared. Okay, if we differentiate each of these, we end up getting 5x to the 4th minus 8x to the 3rd minus 27x squared plus 8x. And so that matches with up here. Now you might say, well, why don't we just multiply these guys out first and then differentiate? Because it seems a lot easier than what you did up here. Now the reason for that is there are going to be times when you can't actually multiply them out. For example, if this function over here was like sine x and this one over here was, let's just say, x to the 3rd minus 4x squared, you can't really do any multiplication here. I mean, you can, but you still end up with more issues. Okay, so you have to follow this rule up here, and you can't just use this. But this is a nice one just to check to see if we're working it correctly or not.